Hello, in this video, we will integrate input icons into an existing Unity project to display the bindings of our tank controllers. In this project, I already imported the tank's template and also the new input system as well as input icons. Let's have a quick look at the example scene and start the game. We can see two tanks are being spawned and I can move them around using the WASD keys and the arrow keys, and I can shoot using space and enter. I can also control the blue tank using a gamepad. Here I can accelerate and brake using the left and right trigger. I can rotate the tank using the left stick, and using the south button I can shoot. Okay, knowing that, let's see how we can use input icons to display some bindings. As the tank's template does not use the new input system, but input icons requires it, we will first have to download the input system through the package manager. In this case, I have done this already, and I also imported the latest version of input icons, which at the time of making this video is version 3.1.11. With these packages installed, the first thing we need to do is to create the input action asset, which will hold the required actions for this game. So let's right-click into the Assets folder and go to Create and scroll down to Input Actions. I will name this asset Tank Controls. Okay, so let's open it up. First, we need an action map, which I will just call Tank. Let's name our first action Shoot and add two bindings, one for keyboard and one for the gamepad. For the keyboard, I will use the space key, and for the gamepad, the button south. Don't forget to save the changes by clicking the Save Asset button on the top of this window. Let's see if we can already display these bindings using a UI image prompt component. For that, I add a UI image to the current canvas in the scene, like so, and drag it up a little bit. Alright, now I add an input icons image prompt component to that object. By clicking the Add button, I can add a new action I want to display. Here I assign the tank shoot action, and I also assign the image component of the current object as a reference, telling the prompt script to display the binding on this image component. We can see that the image does display something, but obviously not the keys we want. The reason being that the script does not know which of the bindings is a keyboard binding and which one a gamepad binding. To achieve this, we have to add some control schemes to the input action asset. Do this by clicking the top left, which says No Control Schemes, and select Add Control Scheme. Now select a scheme name. In my case, I will just use Keys for the keyboard control scheme, and I also add the keyboard to the list of devices. Let's also add the mouse just in case and hit Save. Next, we also have to add another control scheme for the gamepad, so I click Add Control Scheme again. This time, I select Controller as the name. And I add the gamepad to the list of devices and hit Save. Now we need to select all control schemes and go through our bindings, selecting which binding should be used for which control scheme. For the space key, we will use the key scheme, and for the button south, we will use the controller scheme. Don't forget to click Save Asset at the top of the window when finished. Now when we hit play, we will probably still not see any changes, but let's try. Okay, the displayed sprite has not changed at all, and the reason for this is that input icons does still not know anything about the new control schemes we created, namely keys and controller. We first have to tell the tool that it should look for these control schemes when searching for bindings to display. To do this, let's open the setup window through Tools, Input Icon Setup. Here we have two lists of control scheme names, one for keyboard and mouse, and one for gamepads. Remember, we have named our control schemes Keys and Controller, so let's add them to the lists in the setup window. Oh, and while we are at it, I will also add the Tank Controls input action asset to the list below. Doing so allows input icons to save and load binding overrides on these assets at runtime, allowing users to rebind their keys very easily using some prefabs which come with this tool. So now that we have control schemes added to our bindings and input icons also knows about these control schemes, the displayed sprite in the scene should change when we enter play mode. And it does. Very nice. However, when I switch to my gamepad, the displayed sprite still displays the space key, but it actually should display the south button of my Xbox controller. Well, the reason for this is that the event system in the scene is still using the old input system. So let's select that and click the button which says, Replace with Input System UI Input Module. Now when I switch between keyboard and gamepad, events are fired to which the Input Icons Manager can react accordingly. Perfect. Oh, and before we forget, let's exit play mode and replace the old input module with the new one permanently in this scene. Alright, here is one more thing about the control schemes I want to bring your attention to, as it has caused confusions in the past. To show you, I'll open the setup window and the input action asset side by side so you can see. So currently, we have our control schemes set up and everything works correctly. Now look what happens when I change the keys string in the setup window and hit save. The sprite in the scene changes back to the unbound key sprite, which is expected. But now I change the control scheme in the setup window to keys with triple S and keep it this way. To fix the issue, one would suspect changing the control scheme name on the input action asset will do the trick, and they would be somewhat right. But let's see. I select the keys control scheme, click on Edit Control Scheme, and type in keys with triple S. Let's save the asset. Do you notice how although the control schemes in the setup window and in the asset do match, but the displayed sprite remains the unbound sprite? Well, the reason for that is that although we saved the input action asset, the new values have not yet taken effect. Only when we reload the domain, we will actually see the changes. This can be done by entering play mode or by causing a recompilation. It is unfortunate, but I don't think there is anything I can do to change this. Maybe in future versions of the new input system, this will change for the better. Remember, only a domain reload will cause the displayed sprites to actually update. So when you have enabled Enter Play Mode options in project settings, Editor entering play mode won't help you. Let's test this. See, I can enter play mode, but the sprite won't change. Now when I disable the Enter Play Mode options, Unity will reload the domain, and the control schemes in the tank controls asset will take effect. So with that out of the way, let's change the control scheme names back to just keys. Save the asset once again, and let's enter play mode one more time to reload the domain. Great, now that we have already displayed our first binding using the image prompt component, let's try the same thing using a sprite renderer. So I'll create a sprite renderer real quick and attach a sprite prompt component to it like so. This component functions exactly the same as the image prompt component, but can only be used for sprite renderers instead of UI images. So let's assign the shoot action of our tank controls and also drag in the sprite renderer of this object. The key sprite gets displayed, and when we enter play mode and switch between keyboard and gamepad, the sprite also updates, just like the UI image. Nice. Now let's see if we can also display bindings within text components. For this, I will create a Text Mesh Pro object in the UI and add the text prompt component to it. This component functions a little bit differently than the previous prompt components. Let's click the Add button in the inspector and drag in the shoot action like previously. To display the action within the text, let's write our text into the text field above. Instances of the tag Input Action will be replaced with sprites matching our bindings. Here I wrote, Press Input Action tag to shoot. But as we can see, the text in the scene does not show the sprite. Instead, we just see the sprite tag where our image should be. To solve this, we first need to create the necessary sprite assets which Text Mesh Pro can use to display sprites in line with other text. But don't worry, Input Icons provides an easy way to create the necessary assets. Open the Setup window again by going to Tools, Input Icons Setup, and in the second section named Setup for Text Mesh Pro, click the first button which reads Create Sprite Assets. Creating these assets takes a short while, so let's fast forward this a little bit. Great, the sprite already shows up within the text renderer, and our sprite assets have been created within the Resources folder of TextMesh Pro. When we enter Play mode, we also should see the sprite changing when we switch between our devices, given there is an event system in the scene. Alright, with these three components, namely the image prompt component, the sprite prompt component, and the text prompt component, you should be ready to display any binding you want in single-player or online multiplayer games. But since the Tanks template is a local multiplayer game, we will likely want to display different bindings per player. For example, a user playing with the keyboard wants to see keyboard prompts, while another user playing on a controller should see prompts matching their controller. In order to show user-specific prompts, let's create a new UI image and move it to the top left of the screen. It feels quite large, so I'll make it a bit smaller. Now let's add a local multiplayer image prompt component to the object and click the Add button. Again, I'm going to assign the shoot action, and like before, drag in the image component to tell the prompt component which image should display the sprite. All that is left to do is to set the player ID, which I will leave at 0 as this sprite represents shoot action of the player 1. Next, I'll just copy the sprite, move it to the right, and set the player ID to 1 for the second player. Let's copy those images one more time, move them to the bottom, and set the player ID to 2 and 3 for these two sprites. Now we can have prompts for up to 4 players. Don't worry that we cannot see sprites in the scene yet. Once the players join, the prompts will display the device used by each player, though. Next, we need to add the join behavior. We can easily achieve this by using a Player Input Manager component. The Player Input Manager takes a prefab reference to spawn players into the scene. However, that prefab must have a player input component attached, and the tanks we currently spawn don't have those as they still use the old input system. So I will just drag one of them into the scene and create my own prefab out of it and name it Complete Tank New Input. And now I add a player input to that new prefab. Alright, now after we assign the prefab to the Player Input Manager, we should be able to spawn in some tanks. But before hitting play, I'll disable the Game Manager, which spawns in the old tanks. Okay, let's test it. I can join in the tanks correctly, using my keyboard and 3 of my connected gamepads. However, I cannot correctly move them, as that will require a bit of code adjustment. More on that later. For now, I want to finalize the displayed sprites in the UI images. To do so, let's have a look at the tank prefab we are spawning and add a local multiplayer player ID component to it. This component grabs the user ID from the player input component and the device used to join the game and sends this information together with the control scheme name to the Input Icons Manager. Before we have a look at the code, let's change the control scheme values in the inspector quickly to keys and controller like so. Now let's have a short look at the script. In the awake function, the player gets assigned a player ID, and after that, I increase the ID for the next player. So the first player joining gets the ID 0, the second player gets the ID 1, and so forth. In the start function, we grab the device information from the attached player input component and send this information to the Input Icons Manager. And after that, we also send the used control scheme name to the Input Icons Manager. This name depends on the device used to join, so if the device was a keyboard, we send the keyboard control scheme to the manager, and if it was a gamepad, we send the gamepad control scheme. So now when I enter play mode and use my keyboard and my gamepads, we should see the images in the UI updating accordingly. Perfect. There is one more thing I want to add to this scene. I would like the displayed icons to react when a controller gets disconnected or when a disconnected controller reconnects. So, in order to do that, I just create another game object and add the local multiplayer user manager component. This is a simple script which reacts to device changes and communicates with the Input Icons Manager, trying to reassign connecting devices. Now when I enter play mode and a device loses its connection, the displayed sprites will show the unbound sprite for that player. When this player reconnects their controller, the sprites should appear again. Also, the manager remembers previous devices, so in case several players get disconnected, the reconnecting devices will be reassigned to the same player ID as before. For this video, there is one more thing left to do, and that is changing the tank controls to listen for the new input system events. We already have the shoot action defined in our input action asset, but we also need actions for the tank movement. So let's open up the input action asset and add two more actions. I call the first one forward-backward and the second one left-right. The forward-backward action type should be a value, and I set the control type to analog, but I think other types could work just as well. Now let's add a positive the negative binding to this action and name it WS for the keyboard controls. And assign the keys for the positive and negative value. Then I duplicate this binding and name the new binding triggers, as I will use the left and right trigger on the gamepad to control the tank. And now I assign the triggers to the bindings. Okay, now don't forget to select the control schemes for each of these bindings. Keys for the keyboard bindings, and controller for the gamepad bindings. Now for the second action, which is called left-right. The action type is also a value, and for the control type, I will use vector2 this time. With the control type being a vector2, we can add an up-down left-right composite and call it AD for the keyboard bindings. And now I just delete the up-down bindings as we don't need them here. For left, we use the A key, and for right, we use the D key. Now let's add another binding, which is a normal binding, and select gamepad left stick. We are almost done. But don't forget to again check the control schemes on the right side, and save the asset. With the actions defined, now we'll have to adjust the code for the tanks a little bit. So let's hop into the tank movement script. Scroll down to the update method and remove the two lines in which the movement values get set. Then add the following two methods, which we can later assign to the player input component. If your code editor does not add it automatically, then add using Unity Engine Input System at the top of the script. Now let's head over to the tank shooting script. Here we need to do a little bit more, as we also need to handle the charging part while shooting. First, let's create two booleans at the top and call them fire pressed and charging. Then, in the update method, I replace the part where we check for button down with fire pressed and not charging. So this means the fire action was just triggered and we started charging. So I will set charging to true below. Next, where we check if the button is still being pressed, we change it to fire pressed and charging and not fired. And for the last part, where we check if the fire button was released, we change it to not fire pressed and not fired. And since we fire the bullet here, we can set charging to false again. Just like in the previous script, we still need a method we can invoke when the player triggers the shoot action. So add the following method. This just sets the fire-pressed boolean to true when the user triggers the action and sets it to false when the player released the button. Alright, so the only thing left to do is to actually call our new functions when the actions got triggered. So let's select our tank prefab and scroll down to the player input component. If you haven't already, then assign the tank controls asset to the actions field. Then make sure the behavior is set to invoke Unity events and unfold the events list. Then add an item for the shoot action, the forward-backward action, and the left-right action. Drag in any component from the current inspector of the tank object to each action. And for the shooting event, select tank shooting on shooting. For the forward-backward event, select tank movement on movement, and for the left-right event, select tank movement on left-right. And that should be it. Let's test it. Okay, now that we have all our controls for the tanks, let's also display them in the UI. For that, I create a Text Mesh Pro UI text and add a local multiplayer text prompt component to that object. Now I type in FB input action for forward, backward, and LR input action for the left-right controls. Click the Add button twice as we have two actions to display and drag in the forward-backward action first and then the left-right action. And for the action display type, I select All Matching Bindings Single, which should cause the text to display all available bindings for the device. And it does. Awesome. Now let's just copy this text 3 times and move it to the other corners of the screen for the other players. After that, we just need to set the player ID on the text prompt components to match with the other sprite we created earlier. And now test it one more time. All right, the controls for the tanks are working and the sprites get displayed accordingly. Sorry for the messy layout in my scene, but that was not the focus of this video. I am sure you will create a layout, more suitable to display your bindings. Also, if you need a pop-up with a button prompt, have a look at the Input Icons example scene called Local Multiplayer Interaction. Thank you for staying with me until the end of this video. I wish you all the best for your projects and hope you enjoy displaying your bindings with input icons.